Hi there. Let's deal with our next topic in our geology unit, and that is looking at weathering of rocks and how that might produce soil. And so we're going to look at the difference between mechanical and chemical weathering, as well as what makes up good soil. And we'll deal with something called the soil horizon. So in general, weathering, by definition, is the breaking down of rocks and other material of the Earth's surface. It's a slow, continuous process, and it affects all substances that are exposed to our Earth and the atmosphere. There are two types of weathering: rocks on the Earth's surface, igneous, sedimentary, or metamorphic, are broken down either mechanically or through a chemical process. Mechanical weathering deals with forces that break down rocks into smaller pieces, but it doesn't change the overall chemical makeup of the rocks. All you're doing here is we're breaking them up into smaller bits and pieces, but you still have the same minerals and the same type of rock. During mechanical weathering, rocks are broken into different shapes and smaller pieces. At the beginning, the edges are jagged, but through weathering, they become rounded and smaller. What causes mechanical weathering? Several things. Temperature changes can cause the mechanical breakdown of rocks. Frost action. So this picture is showing you how cracks in the rock, water can get in. It freezes. And as you know, when water freezes, it expands and pushes open the big boulders and rock and can eventually crack it. So frost action. Organic activity, which has mostly to do with the movement of animals. So animal actions like this mole, or animals walking on top. Also organic activity in regards to plants. Plant roots can get into cracks within rocks, and eventually the plant root, as it gets bigger and bigger, can mechanically break apart or crack open rock. And abrasion. Abrasion has to do with wind and water, so rocks moving up against other rocks, and gravity, which causes pressure on rocks. The weight of the rocks above it can help crush and crack open mechanically rocks. Glaciers also help to erode rocks. So glaciers can move down a mountain, and as they do, they create abrasion, and that can help loosen the surface of rocks. Let's talk about chemical weathering. Chemical makeup of rocks is changed during chemical weathering. During chemical weathering, changes occur in the composition. So you may have had certain minerals. If it's chemically weathered, you'll get different minerals as a consequence. Minerals can be added, removed, or decomposed. Many substances react chemically with rocks to break them down. And there are lots of telltale signs that the rock is chemically being weathered. One is the rock will turn a different color, so you'll see a color change in the rock. That usually tells us we have chemical weathering. Gases can be produced, causing bubbles on the surface of the rock. So here's some example. Chemical weathering alters the structure of the minerals, and during this you get like this, a whole different color change occurs. Stalagmites and stalactites are examples of some chemical weathering that is occurring inside caves. Oxidation colored these rocks with this boy here. Here are some types of chemical weathering. Water can react chemically with certain minerals, again creating color changes and changing the mineral composition. Air, the oxygen in the air can help oxidize rocks, creating a color change. Carbon dioxide in the air can help react chemically. Some areas have acid rain, especially industrialized areas, and that acid rain that falls down can help chemically wear down rocks. And some plants produce certain acids which might help chemically break down rocks. How fast does weathering occur? Well, we heard at the start of this slideshow that not very fast. However, there are some instances that we could speed up the chemical weathering or the mechanical weathering. Depends on the composition of the rock and the amount of time that it's exposed on the Earth's surface, as opposed to if it's buried. If it's buried, obviously weathering takes longer. But if it's on the surface, then mechanical or chemical weathering can speed up. The ultimate result of weathering is, of course, the formation of soil. Weathering of rocks results in soil formation. Soil is formed when rocks are continually broken down and weathered. As rocks weather, they break into small pieces and eventually into, ta-da, soil. Why is soil so important? Well, plants, of course, depend on soil. And animals indirectly depend on soil since they eat plants and other animals. Don't forget, if you remember the nutrient cycle, basically the sun's energy is converted by plants, and then other consumers eat plants, and then decomposers send the nutrients back to the soil for plants. Living things also rely on soil because they live there. Ants, earthworms, moles, beetles. This is their home, and they burrow and build houses. Soil composition is really important. So when rocks are finally broken down, then what happens is organic material that was once living starts to break down inside the rocks. Incidentally, rock particles still make up the majority of soil. 80% of soil is made up of broken down rocks. The rest is air, water, and organic matter. So if air and water are an important part of soil, then we need to consider something called pore spaces. Healthy soil will have lots of space in them between the soil particles to allow water and air to get in there. So this picture that I'm starring right now, this picture is really dense soil. There isn't a lot of space. It's not very porous, and so it doesn't leave much room for air to get trapped in there, which is important for good soil, and not a lot of room for water. Eventually, the soil could turn really thick and dense, and that would be clay. Clay soil is not healthy soil. It's too thick and dense, no room for air and water. So there's a happy medium. Here's a typical soil profile, and so there are several layers that we need to consider. They're called soil horizons. There's horizon A, horizon B, and then at the very bottom is C, and then below that is rock. So topsoil makes up most of what we call horizon A, and topsoil is very healthy soil. It's usually darker, and it contains something called humus. Humus is lots of dead organic material, keeping the soil darkish. Subsoil makes up most of horizon B. As you can see, it'll be lighter in color because there's less humus. And then horizon C, the bottom horizon, makes up rock layers. So let's talk about horizon A. Horizon A is often called topsoil. You can buy topsoil. In other words, we can make it. And the way we make topsoil is through a process where we fluff up and we screen soil so that it is a rich blend of the right pore size and space. Remember, healthy soil has lots of room for air and water, and topsoil has just the right particle size to allow that. And then you can add organic waste or humus to it. Topsoil is spongy and it will store and hold lots of good water. So horizon A. Horizon B, so water soaks into the ground, washes up, and from horizon A, that's the top layer, it will eventually leach or seep into horizon B. Horizon B is made of clay and some humus. The soil in B is called subsoil. And so again, clay means that it's really dense, not much pore space is allowed. And horizon C, which is the third layer, consists of just partly weathered rock. So this would be an example of horizon C. Those rock particles still need to be broken down a lot more. We talked about mechanical weathering before, and I just want to highlight the importance of how biological organisms help break down rock. And so this is a form of mechanical weathering, but it has a sort of special category called biological weathering. So what does that mean? That means plants with their roots. That means we saw like earthworms, they can biologically break down soil. And then, of course, don't forget the power of water. Let's look at a video clip about weathering.
Now, dear Tim and Moby, what is weathering? From Melissa. Yep, I bet weathering is responsible for those cracks. Weathering is the process that breaks down rocks into fragments and eventually sediments. Soil formation depends on sediments from weathering, and those same bits make up sedimentary rocks. Weathering can even change the Earth's surface over time. Mechanical weathering breaks down rocks without changing their chemical composition. Forces like growing plants, expanding ice, lightning, and mineral crystal growth can all cause mechanical weathering. Plant roots grow into the cracks of rocks where they can find water and nutrients. When these roots get big enough, they'll force the concrete apart. Ice can do the same thing. In cold weather, water freezes and forces rocks apart, creating all sorts of pressure. Then it gets warm and that ice melts, leaving deep cracks and making the rock weaker. Chemical weathering happens when water, air, or other substances react with the minerals in rocks, soil, and building materials to change their chemical composition. When water reacts with the carbon dioxide in the air, it makes carbonic acid. Carbonic acid reacts with the calcite in limestone. Over thousands of years, an entire cave like this can form from chemical weathering. Ah! I'm ready to go. What about you? I think you better find another place to skateboard.